probably start by graphing these points. And man, it doesn't look like a right triangle, does it? None of these angles look like 90 degrees, but we'll prove it in the end. All right, first of all, let's classify this triangle by its sides. To do that, we'll need to know the side lengths. And to do that, we'll use the distance formula. So we can set the distance formula for each side and then simplify. As we suspected, while each side is pretty close to each other, they're all a little different. So the classification by sides is that it's scalene. All right, now to answer whether or not it's a right triangle. There's two ways we can answer this question in this problem. One way would be to see if these three side legs satisfy the Pythagorean theorem for right triangles. C has to be the longest side, so we can test this. The longest side is root 29, so we'll use root 26 and root 25 for the other ones. If this is true, then this will definitely be a right triangle. Not even close. So the answer to this question is that it's not a right triangle. But here's another way of answering the question, is it a right triangle? And that would be to find the slope of each of these sides, because we know the perpendicular slopes are opposite reciprocals of each other. So here's the slope of all the sides, and none of them are opposite reciprocals. So that's another way to answer the question, is it a right triangle? All right, so we use the distance formula to answer that it was scalene, and either the Pythagorean theorem or the slope formula to answer the question that it is not a right triangle.